This will be a demonstration to show you how to prepare our files for 3D printing. I'm going to go back in our history of building the bottle and bring in the surfaces that we had created. I changed these surfaces for the 3D rendering and some of the other procedures, but I'm going to go back and we're in effect going to rebuild it for 3D printing here. So I brought the surfaces in, I mirrored it back, and stitched them together. Normally, we just put a cover on the top, two-dimensional cover on the top and the bottom, and stitch that all together, and then we can create a thickened wall thickness. There's this thicken tool over here, and we can select that and do a thickness. This particular one didn't work when I put the top and the bottom on it, so I'm just going to go about this a little bit differently. It did allow me to thicken the surfaces right here without putting the top and the bottom on it, which was good. So a little bit of a workaround to get this to happen. Got to keep that in mind. There are many ways to accomplish these. So if something doesn't quite work right, to think about other ways to get there. So I'm going to put a cover on here with a thickness to it. So I'm going to create a disc here with an extrusion. I'm going to go a negative 0.09 because that's the wall thickness that I did for the rest of the wall. And I'm just going to make this 2D surface at the top, 3D surface at the top to cover this off. So I'm making that as an extrusion so it has a thickness to it. I'll do this in wireframe so we can see. I'm going to use the oval tool here because this is an oval bottom. So I'm just selecting one side, coming to the other side. I need this to be positive though because I'm at the bottom, 0.09. And then I'm just going to click on the other side. So now I have that closure at the bottom. And this should close up, and then I'll have my my walled structure. Union. Okay, so now I have this completely sealed. It's hollow. I have a 90 wall throughout the whole part. So this is ready for that. So now I need a radius on the top and the bottom. So I can do that now. Since I have a nice thick wall, I can probably get away with about 120 thousandths radius. I think I did that both at the top and the bottom. So I'm just going to select that continuous lines section across the top, go to round. I think I did 0.12. Yeah, looks about right. So now I have a nice radius, top and bottom. So that's ready to go. Normally at the bottom of a bottle, you'll notice that there is a push-up, or sometimes referred to as a punt, a bump-up area in the bottom. That's a couple of reasons. That's for structure. So when you pick it up, the bottom doesn't belly out because of the liquid inside. So it creates structure by having that negative curve at the bottom. And it also reduces the surface contact when you put a bottle on a flat surface. Sometimes if there's a little bit of water on it, the bottle will hydroplane. It'll kind of move around because it's not making contact there. So that push-up area has a couple of reasons, but we're not going to put that in our file because a 3D printer wants a nice flat surface to start with. It wants to print the flat surface, and then it wants to build the rest of the object from that. So in all our files for 3D printing, we're not going to have that push-up. So that's ready to go, and I have my radiuses. Now we need to simulate our finish. The finish is this area, the thread pattern or the screw pattern that we're going to have on top. We're not going to make thread patterns. We're just going to make this as a simulation of where the finish would be. We don't have to worry about the mechanics. And the screw thread, that can be an involved process. I never do it myself. I get the 3D thread patterns from the engineers that create the preforms for these thread patterns that are tolerant to work with certain closures. So I'll get that geometry and I'll put that in the file if I need to. So all we're going to do is just create this 2D closure, 2D wall closure. And then we can do that with our tool in here. Let's see, it's 2D wall, 3D wall. And we can set up the specifications for that, the height and the thickness. It's a pretty straightforward part. There's no real designing going on here. It's just a place to put our closure. So we create that, and then we difference that from that. So let me just ghost this. So we'll difference that, take that leftover disk that's inside, and we'll end up unioning that. In most cases, you're just going to make a straight dowel shape, a cylindrical shape, and then you'll fit your closure on that. Sometimes if it's oriented, we need to have like a little fitting. So you can have, see, I have this little fitting here, this little block that's kind of arbitrary. I just built this little shape here, and I'm also going to put that into the bottom of the closure because my closure is not perfectly round. It's oriented. If it's round, you don't need that. Your closure can just spin around the top of the bottle, so that'll be fine. So in this case, I built that little notch in there, and then I would just union that to my bottle, and then that part is ready to go. So we have to talk about the closure now. So with that simulated finish on top, I need to put an opening into the closure, in the bottom of the closure that will fit over this. So we need to do that with a tolerance to it. So I have these parts here. So I brought the parts up. Let's go into wireframe. There's my 2D closure, and I made this little block. So what I would do is just take those and union that together. And that's exactly what I have in the top of my bottle. So that's the part. And the reason I'm separating this is because I want to create a tolerance that I'm going to use to difference it from the closure. So what we can do is I'm going to grab, select this shape, and I'm going to offset it. Not thicken, but I'm going to offset right here, the first tool down the bottom. Now, offsetting will make a larger version of this. So all I want to do is move this just a very small amount. So I have a clearance. So I'm going to put this at 10,000. So it's 0.01. It'll give me this 10 thousandths clearance. I'm going to click in space here, and you'll see this, it'll move out slightly. So there it is. It moves. So I have a 10 thousandths clearance all around this entire part. And what we're going to do with that is we're going to take that, and I'm going to put that up into the closure and difference that. So we need to prepare the closure the same way we prepared the bottle. So I brought my geometry in. If you remember the closure layer, I had built these two parts. So in this situation here, we're going to take those two parts, and I'm going to union that together. Come on, guys. Take those two parts and union. So now this will be all one piece. And I am going to do my radiusing first in this situation. This, I created the wall thickness in this, and it worked really well. So the radiusing, I'm going to do this separately. I'm going to do this little finger detail here first. I believe maybe 120. Yeah, that looks good. And then these other two sections, I'm going to select that line sequence. And I'm going to select these other ones also. Just this outside one here, and I believe I'm going to pick this little one here also. And I think I did all those at 30 thousandths. This is just to hit off that edge, so it's on a sharp edge. Okay, it's not doing it, so let's do them individually. Let's select that one first, around 30. Okay, and then we'll do this one. That should round. Huh. So that's the one that's not going. Not sure why. I'll select those as individual sections. Maybe that'll help. Okay, we have the other side. All right, let's see if that rounds 30. Okay, so that was it. I needed to take my time on that. I was trying to select them all at the same time. Okay, so we have all that radiusing going on. So then we have to do the same thing. We have to create this wall thickness. Again, I could send this in as a solid, but since I want to open up the bottom so it fits over the finish on the bottle, I'm going to make this hollow. And I'm going to do the same wall thickness. The thickness here, minimum 1.5 to 2 millimeters is a good wall thickness for strength. I will tend to go 60 thousandths to 90. There's a little bit of a range in there. I tend to go a little thicker to make sure that we have enough stability in the part. So that can vary, but they do recommend 1.5 to 2 millimeters. If you have a large file, go thicker. If yours is pretty small, you can go thinner. So again, I'm going to go to the thicken tool. I have this selected, and I have it at 90, and it should go in. Let's see, sometimes it goes out, not went in. Okay, so this worked really well. This is what I had expected the bottle to do, but it didn't, so I had to build it a little bit differently. So now I have a wall thickness. So this is hollow, and I have a nice 90 thousandths wall inside. So that's ready to push the opening in the bottom. So if you remember, I took that finish detail and I toleranced that out. So what I'm going to do is push that up into the bottle structure. I'm going to select that, like a wireframe, view front. So now I have that piece inside and I'm clearing. So all I have to do here is difference that. I'm going to select the closure, difference that from that, and I will have the opening that's going to fit over the bottle. So you can see the disc that's just the center of that part. So we don't need that. So we're going to delete that. Okay, so now this part will fit over the finish that I have on our bottle. So that's preparing the two parts are ready to go. So these are parametric files. We need to send ours out as a wireframe. No, I'm sorry, as a faceted object. So I have the original faceted object that I had sent out over here. I'm going to turn points off because this can get quite complicated looking. Display options. No, don't want that. I want this. Turn points off. I'm going to show you what the file looks like. So here's all the triangulated facets look like. Now, when I originally did it, I did the push up in the bottom. So I'm taking that out to make it a little easier to print. So we're not going to do that. This is what the triangulated file looks like. And I sent this out from Form Z, and I didn't do any alterations to it. I wanted to see how it came out. So it came out a little rough. Some of these spaces between here aren't as fine as they could be. So we can adjust that. So I will help you do this, but we'll adjust our files. So let's say this is our completed part here, and it has the finish on it. So we are allowed to control the mesh on that. So I'm going to select that. And if we go to our meshes area, and if we go to our poly mesh tool, and we select that, we have options over here on how we can work with that. So we will go into use expert options. And let's set this to down here. We have a minimum grid 5 and under U and V. So we set those to 5. And I set this on normal angle tolerance at 5 degrees. Those are critical, all triangles. So let's try that. That's going to give us a denser grid. So if I just click in space with that on and this object selected, it'll show us what this mesh is going to look like. So you can see the difference, how much tighter that mesh is. So this is quite nice, and it broke it up. See, some of these are kind of large, and I'll show you the 3D print in class, but these large surfaces down here are visible. And even in this negative curve here, they're quite visible. But by doing this, we have a really, really nice mesh. So this is what I would save out. So normally if this was the file, we would select this, and then we're going to export. We're going to go not export image, but just plain export. And we're going to come into, you can do an object file, but we're going to do STL. So we select on STL. And these are the files I had sent out before. You're going to do one for your closure, and you're going to do one for your bottle. They have a naming convention at Pratt that we're going to do, but for now, just set it up so you know what it is. I set it up with these two names, and we'll talk about naming for the Pratt 3D printer area. So I'm not going to save this out because I'm not going to use this particular file, but you will just save it here, and it'll be an STL file, and then it's ready to go. And you'll do that for your bottle and for your closure. So that's preparing the file for 3D printing.